This last module is about hormones and how they're regulated and what happens when we can't, okay, which means disease. The objective of this presentation, at the end you should be able to compare the different methods of hormone regulation, in other words, how are hormones regulated and what changes the amounts of these hormones released, and describe some selected diseases caused by some hormonal imbalances. What happens when hormone levels are not correct, can we fix them, and what happens if we fail to regulate those. The hypothalamus controls the release of hormones both by releasing hormones and by nerve impulse. The releasing hormone, for example TRH, causes TSH to be released, which causes thyroid hormone to be released. The levels of these are relatively constant because of the negative feedback pathways involved. The release of oxytocin, ADH, and epinephrine is controlled by the hypothalamus via a nerve impulse, so the nervous system is overlapping with the endocrine system in these examples. Some hormones are released when the homeostatic factor in the blood is detected as being outside of set point. Insulin, for example, is basically the amount of that is controlled completely by how much sugar is in the blood. The next few slides will show how these three methods work in a little bit more detail. Pituitary hormones will turn off hypothalamic hormones. In this diagram, TRH is stimulating the release of TSH, which in turn stimulates the release of thyroid hormone, as expected. However, when TSH levels are high enough, it will shut off TRH secretion, and when thyroid hormone levels are high enough, it will shut off both TSH and TRH secretion. Negative feedback keeps the levels of all of these hormones fairly level. This method is used for all the hypothalamic anterior pituitary hormones. The nervous system may control hormone secretion based on sensory information picked up by the peripheral nervous system or the central nervous system. For example, osmoreceptors can detect whether you're dehydrated or not, and if you are dehydrated, ADH would be released to make you save body water. When a baby cries, that stimulates the release of oxytocin by the posterior pituitary, causing milk letdown to occur, for example. Sometimes the level of a hormone depends on conditions inside or outside the body. For example, what you eat and the nutrients in that food, sugar in particular, control how much insulin and glucagon are released. Calcium levels in the blood are controlled by levels of calcitonin and parathyroid hormone. Can you give another example of a homeostatic regulation of hormone secretion? Maybe sodium, for example, would cause the release of aldosterone if it got too low. Here's a picture of calcium regulation once again as blood calcium levels rise above the 10. Okay, you're going to release calcitonin. Calcitonin will cause you to lower blood calcium. If blood calcium levels fall, parathyroid hormone will be released, tells the kidneys to save or the bones to release, and your blood calcium will go back up. If we don't regulate hormones, homeostasis fails, which can lead to disease or death. So we need to regulate them. Okay? Which way is growth hormone regulated? That's a negative feedback pathway through the hypothalamus pituitary system. Insulin is regulated by a homeostatic level of glucose, and oxytocin is regulated via nerve impulse or nervous system stimulation by the hypothalamus. Okay, antagonistic effects of when hormones are together mean the two hormones have opposite effects. So two hormones that are antagonistic are insulin and glucagon. You would never ever give both of those at the same time, or both of them would never be released at the same time. If sugar is up, insulin's released. If sugar levels are down, glucagon is released. They work opposite. Additive effects is when the two hormones do something together with a greater effect than either one would do alone. Okay, so for example, testosterone and growth hormone are additive when it comes to the growth spurt seen in teenage boys. Permissive effects is when the first hormone is needed for the second one to work. For example, epinephrine will not increase your energy rate of consumption unless thyroid hormone levels are balanced. So if you're hypothyroid, because your thyroid levels are low, epinephrine doesn't have very much of an effect on you. Integrative effects is when hormones produce different but complementary effects. Both vitamin D and parathyroid hormone increase your blood calcium, but they do so in different pathways. Parathyroid says release it from your bones and your kidneys to save it, but vitamin D increases calcium by increasing absorption from the intestinal system. Alright, the next several slides are going to discuss problems with the endocrine system, and essentially all endocrine problems are either you make too much of the hormone or you make too little. Generally, it's much easier for us to treat diseases where too little is made because we can just give you the hormone. One of the most common hormone disorders is too little or too much thyroid hormone. Too much increases metabolism, heart rate, patients might lose weight and be warm all the time, and one of the symptoms, weirdly, is protruding eyeballs. Whereas lack of thyroid hormone will cause the opposite. Metabolism is slow, you may have weight gain, sluggishness, fatigue. If thyroid hormone is low during pregnancy, babies can be born both small and have mental problems. Hypothyroidism in adults usually results in a lower metabolism and weight gain and tiredness, and the treatment, no matter what the reason, is generally give them thyroid hormone. In adults, hypothyroidism is generally called myxedemia, although Graves' disease is a separate disease. It is caused by, it's actually hyperthyroidism because your body makes antibodies that mimic TSH, and if you have too much TSH, you're going to have too much thyroid hormone. Goiter is when you don't have enough iodine, so you can't make enough thyroid hormone. So the symptoms of hypothyroidism are similar to myxedemia, but the reason is in the goiter is you just need iodine. Because iodine was a problem, they had added it to salt to make sure that nobody gets goiter anymore because of that. You don't need to know the different names here, but you should know the general symptoms of hypo and hyperthyroidism. ADH, remember this comes out of the posterior pituitary and tells the kidneys to save water. If you don't make enough ADH, you actually pee yourself to death. Urination is so almost constant that you dehydrate. This disease is called diabetes insipidus. It's not very common, but it's noticed right away because the kid's going to have a wet diaper constantly and be thirsty all the time. And they now do have a treatment for this. They have a nasal spray that helps with treating ADH minus patients. Diabetes mellitus is the one that you're probably heard more often as just diabetes. This one is screwed up blood sugar. Generally, people with diabetes mellitus type 1 don't make any insulin at all. Their pancreas has been destroyed by an autoimmune reaction, and they must take insulin the rest of their life. Diabetes type 2, it happens more slowly over time, and you become insulin resistant and then perhaps insulin dependent. In either case, you're unable to regulate your blood sugar. Adrenal cortex hormones, aldosterone and cortisol, can also be sometimes messed up. Addison's disease is when the adrenal cortex stops making enough cortisol and aldosterone. This leads to pigment changes, impaired ability to maintain blood sugar, etc., or tolerate stress. JFK had this disease, and that was one of the reasons he always looked bronzed or tanned, was because of the lack of adrenal cortex hormones. It can be treated by giving back the hormones. On the other hand, Cushing's disease is when you make too much of this. This makes the person save too much sodium and have higher blood sugar. They tend to accumulate adipose tissue in the face and the neck, causing a moon-shaped face reaction. And it is quite rare and sometimes due to a tumor in the adrenal gland. Growth hormone, too much, is called acromegalia. Andre the Giant had this disease, and it eventually will kill the patient because of too much bone growth. Too little growth hormone can lead to retarded growth. Dwarfism is a result of too little growth hormone or too little number of receptors for growth hormone. There's a couple of different reasons for it, but essentially growth hormone doesn't work. The last objective in Module 3 here is to describe the stress response, which everybody's feeling by this point because hormones, I know, can be somewhat overlapping. First question here, what is stress, can bring all kinds of things to mind. However, physiologically, stress is anything that disrupts homeostasis. So it could be dehydration, it could be loss of electrolytes, blood loss, being extremely hot, extremely cold, injury, or it could be psychological. And it doesn't really matter to the body which one it is, the response is the same. Okay? The physiological response to real stress or imagined stress is the same. So it is real to the person, no matter what it might seem like to the person looking at them. So the stress response is called the general adaptation syndrome to any real or imagined condition that disrupts homeostasis. There are three basic phases: the alarm phase, the resistance phase, and the exhaustive phase. The alarm phase is the first and the main player, and the hormone is epinephrine that is released during the alarm phase. It's released from the adrenal gland, stimulated by the brain when stress is perceived. And the effects are immediate. Heart rate goes up, breathing rate goes up, blood sugar goes up, mental alertness increases, all cells increase metabolism, energy surges into the bloodstream, digestion and kidney filtration usually is reduced, circulation changes, you have more blood flow to your heart and to your arms and legs and less to the gut organs in case you need to run or fight. It will only last a short time, a few hours at the most, and hopefully is enough time to deal with the stress. The resistance phase only occurs if the stress continues. It lasts more than a few hours. There are 5 hormones involved. Number 1, cortisol, which causes a release of energy reserves. Okay, more fatty acids and glucose and amino acids go into the blood. Number 2, renin-angiotensin system and stimulates the release of aldosterone. So aldosterone makes you save sodium and therefore water. This would be especially important if your stress was blood loss. Number 3, ADH, which again saves water. Okay. Number 4, glucagon, increases blood sugar synthesis, makes you have more sugar in your blood, gives you more energy, hopefully to deal with the stress. And last, growth hormone, which is kind of a weird one, but it causes fat release from the adipose, again to give you a little bit more energy. There's no real cause to grow. The idea is more energy. So depending on lipid reserves and what you have available, the resistance phase can last weeks to months, but it's not going to last forever. It can also lead to weight gain if all those extra energy reserves aren't burned. So if you're not exercising while you're stressed, it's just going to be stored back as fat. Long term, if these hormones stay high, you can move into the exhaustion phase. So chronic stress can eventually lead to damage. Homeostasis gets more difficult to maintain and the immune system is suppressed with the high levels of cortisol. The extra fluid increases your blood pressure. Structural proteins may break down. This causes organ damage. The immune system suppression causes infections to develop, which sometimes are hard to heal. Cardiovascular damage may occur because of the long-term increase in blood pressure. Failure to maintain blood sugar can lead to further problems. Fluid and electrolyte balance may be impaired. Usually at this point, you need medical intervention to maintain life, treatment, therapy, drugs, something to prevent further organ damage. So, don't forget you have lots of resources available, your online text, the lesson, and of course your instructor. Hopefully you can now answer, compare the different methods of hormone regulation. How are hormones regulated? What changes the amount of these hormones released? And during disease states, what happens when we imbalance some of these hormones? Can we fix them?